This is our second problem. I already explained all basics for this to solve these problems in the first video, but I still summarize several formulas that will be useful. First of all, the laws that we use. Integral E dot dr around closed loop is 0. Integral J dot ds out of closed surface is 0, continuity equation. And the difference in the electric potential is minus integral, definite integral E dot dr. Magnitude of voltage change across the resistor R is IR, and magnitude of voltage change across a capacitor is Q over C. So this circuit was put together long time ago, which means that we consider a steady state situation. That's why these equations work. Steady state. They work only for steady state situation when all currents and current densities do not depend on time. So I need to follow the rules, and the rules are that we start with some battery. The rules are that step number 1 is find the direction, indicate the direction of current. So let's start with this battery. Current I, let's assume that it flows to the right. Then this current I comes to this junction, and then I have current I1 flowing this way and current I2 flowing this way. Now let's apply the junction rule that tells us that current I flowing in is equal to sum of currents I1 and I2 flowing out of this junction. We have currents, there is no capacitors, so we skip that step. And now we need the direction in which we will go around the loop. So let's have this direction counterclockwise for a change. This is loop 1 and this is loop 2. There is also loop 3, but we know that number of independent equations is number of loops, which is in this case 3 minus 1, which tells us that we can consider just 2 loops. Let's choose this, loop 1 and loop 2. For loop 1, I write integral E dot dr. So I have current I2 flowing down, dr, we will not skip the steps. Current is flowing down, then J is also down, then electric field, which is rho J, is also down. Electric field is down and dr is down, so I put plus. All this is not important because we already see what's happening. Plus I2 R2, IR is voltage change across the resistor. Then we keep going. Those are ideal wires. We close the loop and it's 0. E dot dr is 0, which tells us immediately that current I2 is 0. We shorted out this resistor. We put a wire across it. In this case, it's ideal wire. Current through this resistor R2 is 0. Which means if I2 is 0, then it means that current I is equal to current I1. So from now on, I will just use current I because I and I1 are the same, have the same magnitude. Loop 2. Now we work with loop 2. Where would you like to start? I will start with this battery V1. We go, I decided to go in counterclockwise direction. Fine. So we go in counterclockwise direction, which means this direction for dr. This is dr. From plus to minus, I have negative change in voltage across the battery. Negative change in voltage means positive change in E dot dr. That's why I put plus. Magnitude is V1. Then we keep going in counterclockwise direction. We come to this resistor. current is flowing, this is current I, it is flowing, we choose direction of current, we stay with it. Current I is flowing up, which means that J is up and E is up, but we go in counterclockwise direction. dr is down, E dot dr have negative sign, that's why I put minus. Magnitude is current times resistance, R4. We are right here. Now we keep going in counterclockwise direction around the loop. We come to this battery. From minus to plus, we have positive change in voltage, which means negative change in E dot dr. That's why I put minus. Magnitude, the magnitude is V2. Now we go in counterclockwise direction. This is direction of dr, counterclockwise direction. Current is flowing to the left, which means that J is to the left and E rho J is to the left. dr is in opposite direction to the electric field, that's why I put minus. Magnitude, the magnitude of change of E dot dr across this resistor is IR. Current is I, resistance is R3. Then we come here, we keep going. Next is R2. Current is I2 is 0. This current through this resistor R2 is 0. Zero current means zero change in voltage across this resistor or zero change in E dot dr. That's why I put 0 for E dot dr across this resistor R2. And the last resistor that we have here is resistor R1. We keep going, we go to the left in counterclockwise direction, dr is to the left. Electric field, which is rho J, is to the right. They are anti-parallel, dot product is negative, that's why I put minus. And the magnitude of change of E dot dr across this resistor is current I times resistance R1. And we come back to the battery where we started. We have closed loop, which means that this equation is equal to 0. E dot dr is 0. Okay, so now we have this equation, one equation, and how many unknowns? Just one unknown, current. We can solve for it. What is current? I factor out current from this guy and from this guy and from this guy. What we have now is current is equal to V1 minus V2 divided by R1 plus R3 plus R4. If you plug in the numbers and you find that your current is negative, for example, V1 is less than V2, if current is negative, this means that the direction that you choose is wrong, and in reality current will be flowing in the opposite direction, which is fine. So you find magnitude of this current and you understand that it will be flowing in opposite direction to what you choose. That's why it's really important to indicate the direction that you choose for the current, and you stay with it and you leave it on your paper as it is. This way I know what your answer means. So this current that you found corresponds to this direction, and that's how I will understand that your solution is the correct solution. We found the current.